Okay, so real quick on our warm-up here. What's the area of this square? 16 square inches, right? Length times width. What's the area of the next one? 64 square inches, all right? Okay, on this trapezoid, base 1 plus base 2 times the height divided by 2. What does that give you? 270. Okay, 270 square feet. And then 48 plus 60 times 20 divided by 2 is what? 1,080 square feet. Okay, so today what we're going to talk about is, well, so far in this unit we've talked about how to find the area of all these different shapes. And today what we're going to talk about is what happens when you change the dimensions. What happens to the perimeter and what happens to the area of that figure whenever you change it proportionally, so making similar figures, but what happens to the perimeter and area. Okay, so this is basically dealing with dilations. We've talked about this a couple times this year. So one thing for sure involved in this is scale factor. Okay, we talked about this a couple times. So scale factor is the number multiplied to change the size. Okay, it's the number you multiply by to change the size. And remember, we've talked about it this year. If the number is greater than 1, it's going to produce an enlargement. It's going to get bigger. If the scale factor is less than 1, and not talking about negatives, but just anywhere from 0 to 1, it's going to be going to make it smaller. Okay, another way to think about scale factor, kind of a basic way to think about it is new over old. Okay, and we'll talk about what that means. It'll help us on some of this stuff. Okay, the new length over the old length. Okay, so on this first one, and on all these we're going to assume we're going in this direction, although some of these we'll see that it doesn't necessarily go in that direction, but on all these we're going to assume we're going in this direction. So I want to think about, all right, what is the scale factor to get from this to this? What do you have to multiply this by to get this? Okay, this one's pretty easy to see. It's times 2, right? Because 13 times 2 is 26, 15 times 2 is 30, 14 times 2 is 28. So, I mean, that's what the scale factor is, so that's easy. I want to think about it like this also with this other little thing I told you, new over old. So if we're starting at this one and going to this one, that makes this the old one and this the new one. Okay? So if I put the new length, like I look for corresponding lengths, 26 divided by 13, what is 26 divided by 13?
2.
Is 2, right? I mean, I wanted it to be like as simple as it could be on this first one because it's going to get into ones that are not as simple. But it's easy to see right there. That's all it is. Okay? So on this next one, what's the scale factor?
3.
Is 3, right? Going from here to here, because 2 times 3 gives you 6. 3 times 3 gives you 9. 4 times 3 gives you 12. Okay? Now again, if you think about it as this new over old, so if I take this one and the one that corresponds to it, it's that one. So if I put the new of 12 over the old of 4, that gives me 3. All right, on this next one, going again from here to here, what do you have to multiply 8 by to get 4? Yeah, it's 1/2, right? Or 0.5, however you want to think about it. Or, I mean, just think about it. 4 is half of 8. 7 is half of 14. 8 is half of 16. So in this case, the scale factor is 1/2. Now, I want you to think about it like this again, okay? So if we have new over old, if I put the new of 4 over the old of 8, 8 over 4 simplifies to 1/2 or to 0.5, however you want to look at it. Okay? So on this one, so again, this is why we're thinking about it like that, because the scale factor 10 times what gives you 15?
1.5.
Okay? Good. So the easy way to do that is just to put the new over the old, just to put 15 over 10. which is the same thing as what we would do otherwise. We would say 10 times something gives you 15. Divide both sides by 10, and it's going to give you 15 over 10. Right, so the scale factor is 15 over 10, or if you simplify that, what does that simplify to? It simplifies to 3 halves, or to 1.5, right? Okay, so that's just a reminder of what scale factor is, because we're going to definitely need that. All right, that's part of what we're going to need today. Okay, so on this one, going from this square to this square. First of all, what's the scale factor from here to here? 3. Again, remember the scale factor is just what you multiply by. 1 times 3 is 3. Or if you put new over old, 3 over 1, that's just 3. Now, let's think about this. What would the perimeter of this square be? 4, because remember, perimeter, you're adding all the outside edges. So it'd be 1 plus 1 plus 1 plus 1. So the perimeter of the smaller one would be 4. What would the area of the small one be? 1, because remember, it's length times width. So 1 times 1 is 1. Okay, actually, I'm going to put units on here so this will work out a little better. Okay, now, what would the perimeter of this one be? It's going to be 3 plus 3 plus 3 plus 3, so that's going to be 12 feet. All right, and what would the area be? Would be 9. All right, 9 square feet, because 3 times 3 is 9. Okay. What's the scale factor on this one? Is 4, right? Because 1 times 4 is 4. Or if you put new over old, 4 over 1, that's just 4. Okay, what would the perimeter of that first square be? 4 feet, what's the area? 1 square foot. All right, what's the perimeter of the big one? Is 16 feet. What's the area of that one? 16 square feet. Okay. On this one, what's the scale factor? Good, it's 5, right? 1 times 5 is 5, or if he's putting over old, 5 over 1 is 5. What's the perimeter of this first square? Is 4, and the area is 1. What's the perimeter of this one? Is 20 feet. What's the area? 25 feet squared. Okay. We'll do those others in just a second, but I want to go and I want to look at a pattern that's happening here. Okay, I'm going to go back to this first one. Let's think about this. To get from 4 to 12, what do you multiply by? You multiply by 3. How does that compare to the scale factor? It's the same thing as the scale factor, right? So the perimeter changes by the same thing as the scale factor. Okay, let's think about the area.
It's the scale factor squared.
Okay, good. So notice, does the area just get 3 times bigger?
Yes.
Is 9 3 times bigger than 1? No. How many times bigger is it? I mean, it's 9 times bigger, right? It's 9 times. So it's that times 9 to give you that. Which, yes, exactly, that's right. If you think about it, how does this number relate to this number? It's this number squared. So actually, which is the same thing, but I want us to look at it this way. The change in area is actually by the square of the scale factor. Okay? Let's look at that here. From 4 to 16, what do you have to multiply 4 by to get 16? Times 4. 4 times 4. So how does that compare to the scale factor? It's the same thing, right? But from 1 to 16, what do you multiply by? It's times 16, but really it's by the scale factor squared, right? 4 squared is 16. Okay, on this one, 4 times what gives you 20?
9.
4 times 5. 1 times what gives you 25? 25 or 5 squared. Okay, so that's the main thing that I want you to see today. The perimeter changes by the same thing as the scale factor. It changes linearly with the scale factor. The area does not change by the scale factor. It changes by the scale factor squared. Okay? All right, let's think about this one. What's the scale factor on this one? It's 2, right? 6 times 2 is 12. Or if you put new over old, 12 over 6, that just gives you that 2. Okay, what's the perimeter of this one?
24.
Would be 24 inches. What's the area of it?
30.
36 square inches. Okay, what's the perimeter of this one?
48.
Is 48 inches. What's the area? 144 square inches. Okay, so 24 times what gives you 48?
2.
Times 2. So again, I just want you to see this over and over again. The perimeter changes by the same thing as the scale factor. Does this just get 2 times bigger? No, it actually gets how many times bigger? Yeah, it gets 2 squared times bigger, 4 times bigger, right? All right, on this one, what's the scale factor from here to here?
45.
Is 1/2, right? Or 0.5, however you want to say it. Yep. What's the perimeter of this one? Is 32. What's the area? Is 64. What's the perimeter of this one? 16. What's the area? Okay. So if you think about this, how do you get from 32 to 16? Times 1/2, right? It's half of it. Okay. To get from here to here, do you just cut this in half to give you this?
No.
No. It's actually 1/4 of it, which is the scale factor squared again. If you do 1/2 squared, that gives you 1/4. 64 times 1/4 gives you 16. Okay, one more time. What's the scale factor going from here to here? 12 times what gives you 3?
0.25 and 1/4.
Okay, good. And remember, it's also new over old. So if we put 3 over 12, that simplifies down to 1/4. So the scale factor is 1/4. What's the perimeter of this? 48 meters. What's the area? 144 square meters. What's the perimeter of this one? Is 12 meters, and the area is 9 meters. Okay, so from here to here, it's times 1/4. If you do 48 times 1/4, it's going to give you 12. Okay, on this one, if you do 1/4 squared, that's what, if you do 144 times 1/4 squared, it's going to give you 9. Okay, so what I have written right here is the main thing that we're going to need for today. Okay, if you take the old perimeter times the scale factor to the first, or just the scale factor, it's going to give you the new perimeter. All right, if you take the old area times the scale factor squared, it's going to give you the new area. That's the main thing you're going to need right there. Okay. So on this one, the first thing I need is I want to know the scale factor. So 4.2 times what gives you 6.3? Okay, and the way I'm going to do that is I'm going to just put new over old. All right, so the scale factor is 6.3 times 4.2. So that is the scale factor. So what I'm going to do to find the perimeter of this pentagon R is I'm going to take the perimeter of the old one and multiply it by the scale factor, and that's going to give me the perimeter of the new one. So I'm going to go 35 times 6.3 over 4.2. So 35 times 6.3 over 4.2. What does that give you? 52.5? Okay, next one. So notice this is the one we're looking for, so we're going from here to here. So first of all, what's the scale factor? Good, it's 5 over 15 or 1/3. So I'm going to take the perimeter of the old one times the scale factor to the first power, or just, times the scale factor. 54, old perimeter times the scale factor, 1/3. What does that give you? So the perimeter of that new one is 18 inches. This is going to be 1/3 of whatever this is, because this is 1/3 of that. Okay, now the next one, we've got to notice what's going on here. On this one, we're looking for this one. Okay, so it's kind of backwards of the way we've been doing this on all the stuff so far today. So on this one, this time we're going from here to here. So you got to pay attention for that. Okay, this time we're going from here to here. So 2 times what gives you 8.6? Okay, good. So now notice, since we're going this way, this now is going to be the new one. Okay, so it's going to be 8.6 over 2 is my scale factor. And so I'm going to take the perimeter of the original one, 26 times 8.6 over 2. And what do you get for the perimeter on that new one? Say again? 111.8. Now let's just stop here and see if this makes sense. Okay, this side was 2, this side was 8.6. So going from here to here, did it get bigger or smaller? It got bigger. The perimeter here was 26 and we got 111.8. Did the perimeter get bigger? Yes. So here's the thing. If you if you're not paying attention, you flip these upside down, it's actually going to get, this would have been smaller. And you can look at that and be like, oh no, that doesn't make sense. It had to have gotten bigger. So that makes sense for that to happen like that. Okay, I want you to try that one real quick. Okay, so before we actually work it out, let's just think about this. Okay, so notice, again on this one, this is the one I'm looking for. So this is like the new one, since that's the one I'm looking for. How does 1 relate to 3? It's 1/3, right? 1 is 1/3 of 3. So the perimeter of this one needs to be 1/3 of 15.3. Which, if you think about 15.3 cut in thirds, is going to be 5.1. The answer is going to be 5.1. Okay? All right. So again, this is the new one. This is the old one, since this is the one we're looking for. So if I put new over old, I'm going to have 1 over 3. I'm going to take the perimeter of the original one, 15.3 times 1/3. And if you work that out, you see it does give you 5.1. Okay, so all of those are talking about perimeter. Remember, perimeter is going to change in the same way that the scale factor does. It works right along with it. The area does not change by the scale factor. It changes by the scale factor squared. So on this one, notice now we're talking about area. So on this one, we're going from here to here. So first of all, what's the scale factor going to be? Good, it's 12 over 9, which is going to be 4 over 3. So what I'm going to do is I'm going to take the area times the scale factor squared. Doesn't change by just the scale factor, it changes by the scale factor squared. So we go 18 times 4/3 squared. And what does that give you?
32.
Is what?
32.
32 exactly? Okay, yep. All right, on this one, so we're looking for this one, we're going here to here, so this is new and old. So the scale factor is going to be 3.6 over 6. So I'm going to take the area of the original times the scale factor squared.
45.
Is what?
45. 45.
45? Okay. Okay, and let's just stop for a second. Does it make sense that this could be 45?
Yep.
From here to here, it's smaller. From here to here, it's going to be smaller. So that, I mean, that, as far as that goes, that makes sense. Okay, now notice on this one again, this time we're looking for that one. So actually we're going this direction on this problem. So that makes this the new one, this one the old one. So actually, what's the scale factor on this one going to be?
1/2.
Yeah, we're going,
2, 2, 2.
yeah, we're going that way. So the scale factor is just 2, or 30 over 15 is just 2. So the scale factor is 2. So we're going to take the old area times the scale factor squared. It's not just 2 times bigger, it's going to be 4 times bigger. So it's like going to be 320, 32, 352.
Yes.
Okay, try that last one. Okay, so on this one again, we're going from here to here. So what's the scale factor? 4.2 over 16.8, which is actually, I think it's just some fast 1/4. So we're going to take the area 64 times 1/4 squared. So what is it? It's just 4. Well, on that one, since you're looking for this one, see, this is the one that you're looking for, so it's going from C to B on this one.